Hey, Mr. Canistero here. So we're going to solve a Newton's second law problem where the acceleration isn't just explicitly given to us, and we have to solve for the acceleration and then plug it into Newton's second law, F equals ma, to find the force. So the problem is, while chopping down his father's cherry tree, George discovered if he swung his axe with a speed of 25 meters per second, I'm going to go ahead and underline that, it would embed itself 2.3 centimeters into the tree before coming to a stop. If the axe had a mass of 2.5 kilograms, A, how much force was the tree exerting on the axe head upon impact? And B, how much force did the axe exert back on the tree? So I'm going to go ahead and underline force. So I'm going to make a list of everything that was given to us. I think the best way to start one of these problems is just to make a list to see what we have. So what were we given? Well, it said it had a speed of 25 meters per second, and then it also said it came to a stop. So that speed of 25 meters per second is the initial speed. So VI equals 25 meters per second. We also know that it came to a stop, so our V final is 0 meters per second. We were told that it embedded itself 2.3 centimeters into the tree. That's a distance, so our D equals 2.3 centimeters, which converting to meters is 0.023 meters, because we always work in meters. We were also given a mass, M equals 2.5 kilograms, and we were asked to find the force. Another thing is, since we're doing Newton's second law, we know F equals ma, so we know eventually we're going to have to find an A also. So what we're going to do is we're going to use the information given to try to solve for A first, and then we're going to go ahead and try to plug that into F equals ma. Well, we were given a VI, a VF, a D, and we're trying to find A. Going to your reference tables, you'll see the equation to use is VF squared equals VI squared plus 2AD. Oh yes, we're getting back to all that kinematic stuff. Everything we learned in the first unit is starting to come back. Plugging in, we get 25 meters per second squared equals 0 for the VI. Oops, I had them backwards, didn't I? So we'll do 0 squared equals 25 meters per second squared plus 2a times 0.023 meters. Going and solving for a, I'm going to square my 25 and subtract it over. So squaring 25, I get 625. And then I'm going to divide by 2 times my 0.023 meters. And I get an acceleration of about 13,587 meters per second squared. So that is a fast acceleration. And it is a negative acceleration because it's decelerating the axe. Now what I'm going to do is I'm going to go solve for the force that the axe imparts upon the tree. Well, Newton's second law says that F equals ma. Therefore, the force that exerts is the mass of the axe, so 2.5 kilograms, times the acceleration, or I should better say the deceleration of the axe, which is negative 13,587 meters per second squared. Going and plugging it through, I get a force of 33,967 newtons. And again, that is a negative force because it's in the opposite direction of the swinging of the axe. Namely, the axe is being swung into the tree, and the force is being exerted in the opposite direction. That's why it's given a negative. Now that's part A. Part B is, how much force did the axe exert back on the tree? Well, that's Newton's third law thing going on, because the action force was the tree exerting a force on the axe. The reaction force is the axe exerting a force back on the tree. So we see, for part B, the force is exactly the same, just the exact opposite. So 33,967 newtons. All right, so there's a moderately complicated Newton's second law problem where we weren't given the acceleration explicitly. I hope this helps.